Hello and Assalamualaikum to all panelists and viewers of my presentation. My name is Muhammad Azri Fikri bin Arbain, a final year student of Mechanical Engineering Bachelor's degree. Today I will present my FYP proposal, which entitled Effect of Mixing Parameters on the Synthesis of Eggshell-Derived Hydroxyapatite Powder. My supervisor is Dr. Natasha Ahmad Nawawi, and my co-supervisor is Dr. Rozlin, Muhammad Masdek. I will start my presentation with my project introduction. So this project will be related to biomaterial preparation. Biomaterial is a substance that has been engineered to interact with biological systems for medical purposes. Biomaterial is divided into 4 groups, which are metal, polymer, ceramic, and composite. This project will be focusing on hydroxyapatite, or which also known as HA, which is one of biomaterial and classified as bioceramic. There are two factors that will be influence the characteristic of the produce HA, which are preparation methods and mixing parameters. And this hydroxyapatite can be synthesized from commercial chemical and organic source of calcium. Now I will continue with literature review. This section contains 3 subtopics. The first one is hydroxyapatite and its application. Hydroxyapatite or HA is a type of calcium phosphate mineral with specific composition of Ca10PO4,6OH2, and it has specific diffraction structure, which is hexagonal system and space group. HA has been commonly used for medical purposes, especially in orthopedic and dental application. The reason why HA has been preferred by researchers in medical field is because of its properties, which is as good chemical and thermal stability, distinctive sorption capability, and biocompatibility. Example of medical application for HA is bone repair regeneration, dental implants, toothpaste additive, and drug delivery system. The first time HA has been discovered to be suitable for medical application was in 1926 through research done by De Jong. This research has been found that there are similarities in terms of crystalline structure between bone mineral and HA. Other than medical application, HA also can be used for non-medical application, such as for column chromatography, water defluoridation, chemical gas sensor, and heterogeneous catalysis. There are also studies been found that HA have a capability to fight water, air, and soil pollution due to its great sorption capacities, acid adjustability, and ion exchange capability properties. The second subtopic is hydroxyapatite preparation methods. There are various preparation methods available nowadays to produce HA, and it is divided into 4 types, which are dry method, wet method, high temperature processes, and combination method. Every method has its own different outcomes in terms of phase stability, surface morphology, and chemical composition. To obtain high purity HA, certain parameters need to be controlled during the synthesis process, such as heating temperature and stirring technique. The first preparation method is dry method, which is the method being done without any involvement of solvent, and it is done in dry condition. The method was known as the most cost and time efficient method due to its procedure that the produced HA is not strongly affected by the processing parameters, and it allows the method to mass production. Example of dry method is solid state reaction and mechanochemical method. Next, the second HA preparation method is wet method, which uses solvent and aqueous solution as the precursor and reactant during the process. There are many advantages of wet method that make the method as the most preferred method among researchers, which is it capable to produce the nano-size HA particle. Morphology, structure and the powder size can be controlled, and it is easy to conduct. However, there are also disadvantages of wet method, which is produced HA will have a low crystallinity degree compared to dry method. Example of wet method is wet chemical precipitation and hydrolysis method. The third one is high temperature processes, which the synthesis process occurs with the use of high temperature to decompose the precursor. This method is known for its high crystallinity and good chemical homogeneity product. However, research found that there are existence of other phase impurities in it. Example of high temperature processes is combustion and pyrolysis method. And lastly, the last HA preparation method is combination method, which it combine two or more methods to produce the HA. The advantages of combination method is the characteristic of HA can be improved. However, it will be costly and the procedure will be more complicated. The example of combination method is mechanochemical hydrothermal method. In terms of preparation method, this project will be focusing and be using solid state reaction, which classified as dry method. Solid state reaction usually start with calcination process of both calcium and phosphorus precursor to decompose remaining organic metals and to form a proper crystallized structure. It is then will be mixed and stirred together to speed up the reaction or improve mixtures. Once mixed, the mixture will be ground using mortar and pestle for a duration of time to form a homogenized powder. And lastly, the powder will be heat treated at a high temperature and followed by rapid cooling in a room temperature to form HA powder. The advantages of solid state reaction, it can mass product for commercialization, simple procedure, and can produce high purity HA powder. However, it comes with disadvantages where the produced HA sometimes exhibits heterogeneity in its phase composition. The third and last subtopic for literature review is hydroxyapatite source of calcium. Hydroxyapatite is a biomaterial that mostly consists of calcium. The calcium sources can be either a synthetic source or organic source. Example of synthetic source are calcium chloride and calcium nitrate tetrahydrate. However, it is more preferable to use organic source due to its high possibility to be accepted by living organs due to its physicochemical similarity to the human bone appetite. Example of organic sources are animal bones such as bovine bones and fish bones, biogenic waste such as eggshell, and also calcite plant that can be found under sea, such as red algae, coral, and also seashell and starfish. Next, we will proceed to problem statement and objective of the project. In medical application, it is preferable to use nanoparticle HA. However, there are problems such as HA particles sometimes agglomerate during mixing process, and HA purity can be affected by contamination during heating process. However, in case of HA purity, ball milling process can induce the risk of contamination that affects the purity of the product. And in terms of particle size, in this project, a various of stirring time will be subjected during mixing process to observe the effect towards the particle size. The objective of the project is to synthesize Eggshell-Derived POHA powder using solid-state reaction method. And the second one is to establish an optimum mixing time to synthesize HA via solid-state reaction method. And lastly, to investigate the effect of different stirring time on phase stability, surface morphology, and chemical composition of the synthesized HA powder. Scope and limitation of the project. This project will be entirely based on experimental works. HA powder will be produced using the solid-state reaction method. Eggshell will be used as the source of calcium. The project will only observe the effect of mixing stirring time, which are 1, 3, and 5 hours towards the phase stability, surface morphology, and chemical composition of the produced HA powder. This project will be done at UiTM Shah Alam Laboratory using equipment such as X-ray diffraction and scanning electron microscope. However, if the MCO prolonged due to COVID-19 outbreak, there is a possibility that the experimental work could not be conducted physically at laboratory. However, it will be redirected into an alternative research method instead. Methodology of the project. This is the flowchart of the powder preparation process that consists of eggshell calcination and solid-state reaction. The powder preparation process will be started with collecting eggshells as waste from the nearest cafe to save cost. The eggshell then will be cleansed thoroughly to remove any dirt and inner membrane layer. It will be crushed and ground to form fine powder by using pestle and mortar. It is then subjected to calcination to produce pure calcium carbonate to be used as calcium precursor. The optimum calcination temperature will be selected based on the phase purity shown at the XRD diffractogram. That complete the calcination process. It is then to start the solid-state reaction. The calcium and phosphorus precursor will be weighted according to the molecular weight that will be obtained through calculation. The obtained calcium precursor from calcined eggshell will be then added to the phosphorus precursor, which is this dicalcium phosphate dihydrate at a CAP molar ratio of 1.67. The mixture then will be subjected to mixing under magnetic stirring with ethanol as a solvent at a speed of 400 rpm and various stirring time of 1, 3, and 5 hours. Once mixed, the mixture will be dried overnight inside an oven with a temperature of 110 degrees Celsius. The dried powder then will be sieved to obtain a fine and uniform powder. It is then subjected to uniaxial pressing to compact the powder to ensure the heat treatment that will be done after this go evenly. Then the heat treatment will be carried out at a predetermined temperature to obtain homogeneous composition. And lastly, the compact thermal treated HA will be crushed and grind to break the particle agglomerates and for characterization purposes. This is the sample characterization and evaluation process. There are two equipment that will be used to characterize the sample, which is X-ray diffraction (XRD) and scanning electron microscope (SEM). XRD will be used to obtain information about the structure of crystalline materials. The sample will be carried out at room temperature, operated at 45 kV and 40 mA, using copper K alpha as the radiant source. The X-ray step size is 0.026 degree, with the scan angle 2 theta varying from 10 degree to 50 degree. The second equipment is scanning electron microscope (SEM), equipped by energy dispersive X-ray (EDX), is used to observe surface morphology and microstructure features. The sample will be examined under SEM at an accelerating voltage of 15 kV at magnification up to 30,000 times. Expected result of the project. The first expected result of the project is high purity crystalline HA powder will be successfully produced using calcined eggshells as the calcium precursor via the solid state reaction method. The second one is a process which involves proper homogeneous mixing time of the starting materials and heat treatment of eggshells is developed. And the main expected result is HA powder should be nanoparticle size and have a high surface area. The planning of the project. In this figure, it shows the Gantt chart and flow of my project for FYP1 and FYP2. References. This is the references I've been used. That's all for my presentation. Thank you for your time to listening to my FYP proposal presentation. For any question, you can contact me through my email at azrifikri@gmail.com and my mobile number 019-615-3646. Thank you.